So there's been some questions on how to do the problems that ask you to sketch f prime of x based off of f of x. So I'm going to go through a little bit of that and so that you can see. You're using the information that you know about f of x. And what the derivative is saying is the derivative is graphing the slope of this graph here. Okay, so the slope values. So the first thing that you're going to look for is anywhere where the slope equals 0. So notice that right here on the graph, the slope, if it had a tangent line going through it, would be a horizontal slope, which would be a 0 slope. So we know that this graph will equal 0 at 0, okay, because the slope is 0 at 0. Okay, now the other thing that we know about this graph is that this has an increasing slope the entire time. Okay, the only time so the entire time it's increasing except for at this 0, it's 0. Okay, so what that means for this graph is that it will the whole graph has to be above the x-axis. Okay, there's nothing in this graph that will be in this lower part because this is always increasing, which means the slope is positive. Okay, and this is a graph of the slopes of this graph. So because the slope is always positive, it'll be this way. Okay, now the other thing that we know about this graph is that this part of the graph here, I guess I'm not going to talk about concavity. Sorry, I was going to go into concavity, but we're just talking about the first derivative. Okay, so we know that it's going to be it's always going to be positive. We know that it is going to touch 0 here, and you start to kind of get an idea of what the patterns look like. It just says sketch a possible graph. So this possible graph is a parabola here. Now the other thing you can think about is that this is a graph of an x cubed function. When you take the derivative of x cubed, it brings it down to an x squared function. When you take the derivative of an x squared function, it comes down to a linear function. So the graphs do progress down. If you know what the shape of a general graph looks like, they still progress down into those family of graphs. So let's look at this one. This one's also this next one is also a cubed function. And so we're just going to look at it the same way though and see where it equals 0. So on here, you can see that this graph has a few places that it equals 0. It's anywhere where the slope is changing directions is what you're looking for. So on here, you can see, I'm going to zoom in even just a little bit more so you can see this. So see here at about 1/2, it's actually more like probably a third. You can see my pen will let me write here. I want a different color anyway. My pen does not like me writing dots. Okay, so here there's a tangent slope that is equal to 0, and here. So you're looking for where it's changing directions, okay? So then when we go to this other graph to try and graph that, we know that it equals 0 at about 1/3, so about where that other one was. But on the x-axis, it's going to equal 0 when x is about 1/3. And when x is about equal to 1. Okay, so it has these 2 points here. Now, the other thing is we have to look at what's happening to the graph. So the graph is increasing from -infinity all the way up to this 1/3 type spot. It's increasing. And then it decreases in between these 2 points, and then it increases. So the slope will be positive. In between here, it'll be negative, and then it's positive again. So what that means for the derivative graph is that it is above the x-axis on both of these 2 ends, and it will be below the x-axis on these 2 ends. So it is also a parabola that goes through, and it's going to go through the 0 at each of those points, and that's a terrible picture, but you get the point that it's going to be a parabola. It'll probably just be a really skinnier one, would probably look better. And it's going to be below. So let's try and correlate these 2 things. It is a negative it's on the negative side of the x-axis when the slope is negative. It is positive or above the x-axis on both sides of this, because this is positive. See how it's going up, and this is positive. If you move, and when you ever are looking for a positive or negative slope, you're moving from left to right when you read the graph. So see how it's going up and then down and then up when you move from left to right across the graph. Okay, so that means it's positive, and then it's a negative, and then it's a positive. Okay, let's look at this one. So now this one is very similar too. So let's look at this one, and then we'll move. The next one's different. So this one here, it has a changing slope, or a 0, meaning that it goes from a negative slope back to a positive slope right there at 0. So we know that it's going to cross the x-axis at 0. Okay, then here we know that it is right here is where it's changing directions to, going from a positive slope down to a negative slope. And that's about like 1, not quite 1.5. So about here is also where it's going to equal 0 on the x-axis. Okay, that's when the slope equals 0. So then we have to say, okay, which way is this parabola going? Well, here it's going to be negative until we get to here, which means it has to be below the x-axis. It'll be positive in between, and then negative again. So this graph comes up, and it's just telling you to write a possible graph. So you don't have to be really accurate with those. They're actually pretty, you should do it this way here. Okay, so let's look at another one. Okay, so this one, now there isn't anywhere where it's changing slope. So because we're looking at what the slope is doing, here it is, the slope is consistently decreasing, right? So it's decreasing all the way to here, and this one is also decreasing. So you could say, okay, the whole thing is decreasing. It has a decreasing slope. So what that means, oh, it doesn't like me to write that fast. A decreasing slope means that the slope is going to be, everything is going to be under the x-axis. Okay, so that's the first thing you need to know, is nothing will be in this upper part because the slope is always negative. So you're never going to go above the x-axis in this graph that we're drawing here. Okay, so then we're going to go in here and we're going to say, okay, now what is happening? Well, we know that it has an undefined point at 3. Okay, so there's an asymptote at 3 there. So I'm going to put a little dotted line here at 3 that's supposed to go straight along that line. Okay, so now we know that on this side, so let's just look at this graph first. We know that the slope is isn't very big, right? It's just small numbers. Like the slope here, you know, it would be a smaller slope, and it gets steeper and steeper and steeper. And so when you're looking at that, we know that this is where the values are going to get larger and larger in the negative direction. And so it has this same type shape that goes down here, okay? Now the same thing with this, except for your slope starts out really, really big, and then the slope gets a little bit less. And so this one's going to start really, really big values and get closer up to smaller values. So so that would be a possible graph of what's happening to that one. And so let me make sure that we're seeing what's happening here. Okay, so the slope is how far up and over, right? So slope is equal to rise divided by the run. Okay, so this one here, if we look at the rise over run from one point to the other, it is going down just 1 for over almost 3, right? So this would be the slope at this point is about -1/3. Okay, I'm just estimating what that is. Okay, so that's a really small value. Well, that 1/3 is going to be what's measured on the y-axis. Okay, so the 1/3 is about here. So that's why I have that up closer, where the y value represents the slope. Okay, now here, the slope from this point to this point, I mean, you go over 1/2 and you go down 2. So it's negative, let's do -1/2 divided by 2. I'm just estimating these values, okay? So then this one is like multiplying. So this is now, I'm going to be at like a negative, well, it's going to be even more. Anyway, so this value, this slope is getting larger and larger. Let's not do this as an example. This slope, see how much steeper this is? See how this one's going down just a little bit and over a lot? And this one's going over a little bit for down a lot. So this value is bigger that's going to go down. And so it's a larger number on the y-axis because the y-axis represents the slope.